So yeah, I'm going to start simple. First of all, D is the best language. Phobos is the best standard library. That's my talk. Thank you. Unfortunately, I have some time to fill. So like the one major problem that I think that we have is we have too few people. Like we need more warm bodies on everything that we want to do. And there's sort of one problem that I think that we can somewhat easily solve, and that is like we have our issues and sort of the things that we want to do in Bugzilla, and there's nobody on Bugzilla. Everybody's on GitHub. So if we look at the stats, it's pretty obvious. Like GitHub has like 83 million people give it a change, and issues.dlang.org maybe 12, maybe 13 now. So like there's no comparison. We have to get away from issues.dlang.org and move over to GitHub. Because like we not only want like the high of the best and everybody's awesome people, we also want the regular JavaScript user that thinks maybe I should try this. Yeah, people are sort of making weird sounds, but we want those people. We need more warm bodies, and actually the JavaScript people have cool ideas as well. And so we have to get everybody in there. And like writing the tool for this is actually quite easy. So we get the open issues of Bugzilla. We get the data via the REST API of Bugzilla. We find the participants of all those issues in Bugzilla, and many of them have accounts on GitHub. So basically, like GitHub is a good superset to issues.dlang.org. We do a bit of markdown formatting because Bugzilla is using some XML and GitHub is obviously markdown. And then after we have done that, sort of merged the issues with their user accounts on GitHub, we push the stuff over and everything's happy. And but talking about this is really, really boring. Like everybody could do this here probably like tomorrow if they had the energy to actually do this. So we're not going to talk about how to do it because that's like everybody could do it. It's just boring. So while sort of trying to come up with a talk, what often happens, you have an awesome idea for a title, but you have no content. And I had that problem 2 weeks ago. I had a good title that was accepted, but no real content. And I was looking at the source code to find interesting stuff to talk about, and there was nothing. It was all very, very boring. But then I realized that a couple years back, somebody said to me, yeah, Phobos might be great, but I have no time to learn it, so I'm just going to write all my stuff myself, because then I don't have to learn Phobos and look at the documentation and all that. And I was thinking, that is not a good state to be in. And sort of while scrolling through the files to desperately find something interesting, I realized something odd, maybe. So if I look at all the headers, so all the import statements of the 10 file making up this project, they all look the same. And it's all very boring. And I think that is the magic of D on Phobos. Like everything becomes boring, and that is awesome. And I think it becomes boring and thereby awesome because of Phobos. And if we look sort of at a smaller example, we have stuff to basically do a bit of string formatting to create like a string that we can pass to a function to get data from an API, pass it into JSON and return it. This is super boring and it's awesome and it just works. Thank you, Phobos. And then you get some JSON, you think, oh, now I have to, pardon my French, you now have to create a parser for that. And obviously, D doesn't have like a serializing, deserializing library, but I think the reason is not that nobody has done the work to do it. I think it's so easy to roll your own when you're doing it that there isn't really a need to do all that work because there's always something a bit different and there's some weird edge cases that the serialization library will not catch, so you just roll your own. And actually, we're going to do this. So when you run this request to get the bug, you get some JSON back. And there are a couple of other APIs you have to hit when you write code to transform Bugzilla issues to GitHub. And like the structure there is the same. The same oddities exist between the different APIs. So maybe we can do a bit of like template metaprogramming to solve or to stop ourselves from rewriting stuff over and over again. So the first thing you usually do, you define your structure. So a simple bug structure. And maybe you can sort of see the first problem coming up. There's an alias underscore in there. And actually, in that data, Bugzilla allows you to have aliases for other bugs. So if like there's duplication, you can sort of assign an alias. But obviously, if you miss the underscore there, you will have a keyword used as an identifier, and that doesn't work. So you have to put in an underscore. This is like one of the corner cases I meant earlier. And then what you do, you write a simple function, t from JSON to t, basically. And I think here again, this code looks complicated, but actually it's very boring. The interesting bits are basically the static ifs identifying where something special has to happen, or where you want to treat the JSON that you have in a different way than like sort of the regular way. Here again, Phobos is helping. So we can simply test if the t that we are currently looking at is an array, and sort of one of the interesting sort of practicalities of D means that you also have to check that it's not a string. But it's already there, so import std.traits. These are the traits that you need to know, and if you know them, those are like 99% of your use cases. And you don't have to do any type of is shenanigans to get the correct Boolean value. Know this and you're good, like I swear. If not, come next year to DConf and I'm gonna buy you a beer maybe. And going on from there, so obviously we have JSON, and then like one of my probably favorites, map. Map is basically this, and everybody has written this code. And if you write it again after this talk, I'm gonna come to you and you have to buy me something to drink at next year's DConf. Because if you write this over and over again, you're doing something wrong. Import std algorithm iteration, map, and you're there. Like this happens all over the place. And so basically the idea of map is you pass in an alias to something that you want to call on the elements of a range or an array. And I sort of abbreviated this here to an array because it's easier to understand as sort of somebody learning Phobos right now or learning D. So basically what you do, you first sort of have to do a bit of shenanigans to get the return type of the function, because that is basically the element type of the array that you're returning. And then you just iterate over your input, call the function with the current element, append that to your new range, and then return that. And obviously, if you do it with a map of Phobos, this is all lazy, and there's sort of always only one element in use. The other interesting thing that always goes together with map is filter. And here, basically, you pass in a predicate saying, if for this element it's true, keep the element, otherwise kick it to the curb. And everybody has written this code in this audience. Like, I bet 100% everybody has written this code. And now you don't, because you know there's a function called filter, and it does it for you. All you have to do is define your predicate, hopefully test your predicate, because sometimes you screw up defining your predicate, and it works, and it's done, and it's awesome. And it's also boring, and boring is good, as we have learned. Also, JSON parsing. This might not be the best JSON parser out there, but we don't have to care. Like, if you have to parse terabytes and terabytes of JSON files, you have other problems than std.json. And I bet for 99% of your use cases, std.json is just perfect. It works, and you go on. So another thing that I think is extremely valuable, but I hardly see being used, is enforce. Enforce is an awesome function in std_exception. You pass in a Boolean, and if that Boolean is false, you throw an exception. So usually what happens, you have source code that looks a lot like this. If some condition is false, throw an exception because something is off. And you always have this nesting. And quite often what happens is, like, you have an else case and your indentation sort of grows bigger and bigger and bigger. And with enforce, you just say enforce, is the type actually an object? If not, throw an exception and create a nice error message that actually might help the user. So std exception enforce, remember now. Another really goodie is SysTime and Date, and then also date time. Like, you don't want to parse date times. Like, parsing date times is pretty much the bane of all software developers. And especially like date and date time, if you know you're gonna get ISO format, might just be okay. But parsing a time zone of a SysTime, no. Like, you're gonna get a lot of gray hair doing that. And trust me, you don't wanna have a lot of gray hair. And that basically continues. Like, it's basically always, you have static if statements saying there's something special, do something different, but the rest is just calling Phobos functions. SysTime here, like calling it recursive, std.traits, it's all very straightforward if you sort of learned a tiny bit of Phobos. And those are the functions that you need to do this. Like the rest is basically, fluff going around there. And suddenly, you can use JSON for the rest. If you actually have if you're down to the basic types here, you can just sort of get a Boolean out, get an integer out, get a string out, whatever you need. So this basically is the function that does all the work in the library or in the program I wrote to do the transformation from Bugzilla to GitHub. The other unfortunate thing that I had to do is, the idea is only to transfer the open issues, because you can't guarantee that when you move from Bugzilla to GitHub that the IDs stay the same. And that is obviously not good, because there are a lot of IDs in the source code saying this unit test the bug for ID whatever, and we don't want to change those in a go when we transfer the issues. So I had to get the open issues, and unfortunately the XML returned by Bugzilla isn't actually valid XML, and I was like, oh god, this is going to be horrible. And actually, the interesting thing is then I looked at the HTML that is generated on the page for the open issues, and I was like, I'm not going to pass the HTML, but maybe I can do a small hack to actually get the data out. And let's be honest, quite often what we do is a small hack to do something and then move on. And so again, basically the idea is we sort of define the structure that we want. We want sort of a bug data. And another thing that is interesting, so Bugzilla is somewhat slow, and you don't really want to get, whenever you test, to get all the bugs, get all the sort of content of all the bugs by the REST call. That just takes forever. So basically what I wanted to do is to have a bit of incrementation in the work that I'm doing. In the end, I can just sort of get the last updates and call that in and be done. So I have to save the data as well. And then again, we're going to use net.curl.get to get the data. And then we split the HTML into two separate arrays. The first one is the date times, and the second is the ID. So basically, you're binding the ID to the last time that bug was modified. And again, a bit of checking there. And there is another interesting function that is zip. So zip basically allows you pass in two or more. So this is just sort of a abbreviation to show the example. You pass in two or more ranges, and you get something back that iterates them in lockstep. And here basically what we do is we pass in an A and a B, and we check that they have the same length, because otherwise you couldn't sort of iterate them to the end together. And then we are basically creating a new struct and returning that. Like everybody has written that code. Now you know its name, it's zip. It's an STD range. Never want to see that code in code review again. Another interesting, sort of one of the hidden magic things of programming is with sort and unique, you can pretty much solve all programming problems. And unique is, as the name says, a function that returns a unique thing of what you passed in. And that usually requires that you sort beforehand. But luckily, the data that I got passed, the sorting was already done by Bugzilla. So all the IDs were already sorted, so I don't have to do the sort. And that is sort of the trick to get performance there. You only have to do the unique. And unique is basically this. You take the element, and if there is no element before you, or if there's an element before you, you check if you're the same. And the checking is done again by a predicate you pass in. And if the predicate returns false, so you're not the same as the previous element, you sort of continue with that element. And also this is the actual implementation is a range, so it all composes nicely with map filter and all the other range functions that are there. So this is the whole function to basically pass the HTML into IDs and unique those IDs. It's really boring. I mean, the only somewhat interesting part is the CT regex, and that is basically compiling a regular expression at compile time to something. And then we use that to match against the whole string, which gives us something that we can iterate. And then we just have sort of a nice functional style where we filter out all those lines that didn't match anything. Then we take the first element, because from looking at the HTML, I know that there's only one ID per line. Then we find those matches, we remove everything from the string that isn't a number. And again, is a number, is member, like there are actually multiple implementations of is number, so for Unicode and for non-Unicode. And we get then the function until, which basically iterates a range until the condition is no longer met. So until is something to remember as well. And the first one that is used is find, and find is exactly as you think. You remove elements from the array or for the range until your predicate is true. That's it. And everybody has written that code. So no longer write that code now. And as I said, until is basically like sort of the difference to find. It's sort of you continue until the condition is true, not sort of you drop everything after that. And the interesting thing, if you look into Phobos, until is actually implemented by calling find in the end. So everything boils down to find basically in STD algorithm searching. And so if you know find, you have sort of an idea of that there are other things that can help you in that regard as well. And then like this is the best function ever, to. To, like when on the surface it's like, this isn't as interesting. I put a string in and get an int out. But you can basically put everything in and you're going to get everything out. And after the talk, you probably should look up those Unicode characters for the emojis related to them. I didn't really want to put them here on the slide. And that's like you can basically put everything in and get everything out. That's the best function ever. So remember to. It's from std.conf. So at this point, I wanted to sort of like show the splitID function without doing Phobos. But then obviously I realized that I haven't shown how the regex implementation is done, and that is like a whole other beast. But just for comparison, we had a very sort of, I would say, readable short function, and this is only part of the function without Phobos. And actually, I'm lying to a degree because like front, empty, and pop front are still Phobos functions, and that is like a whole nother mess we don't really want to get into. So like if you have code review and you see this, yell at the person and say, use Phobos. So there are a few last things that we have to sort of present in a Phobos tutorial for newcomers. Like one of the coolest function ever is std format. On the surface, you think it's printf, but actually there are a lot more things. So like if you use the s modifier, you can basically pass everything in. Be it a string, be it a struct, be it a number, as always works. You don't have to make sure that you get the right identifier for it. And that in itself is still type safe, and it just works. Perfect. Float formatting is also, as you would expect from printf, but also not everybody knows printf. So as it's a tutorial here, we're going to do it very quickly. So give a number, give a dot, and that's the precision of the float that is going to be printed. You can also define the order that you want to select. So that is just number $. So on line number 3, you would expect normally that you get out AB, but actually as I sort of reversed the order with the numbers, you get BA. And then, like on the surface, also a very boring feature, but extremely powerful. When you write decode and you want to have very long numbers, like very long constants that you have to write, you can separate them by underscores, and that still pass as a number. And you can also go the other way through format. So if you say comma 3, you will get a comma every third digit you print. And you can also define the character that is separating there. There's a question?
Why would you use the $ and not just reverse them in the string and place them in the right order?
Come again?
Why would you use the $2 and $1 to swap them and not just have them in the right order to begin with?
So sometimes, for instance, you find the situation that you have to use a parameter to the function to format multiple times. So for instance, if you want to print AAA, you don't want to pass AAA as parameters. You want to only pass A once. And then you can say, $1, $1 multiple times in that string and get that as well.
Okay.
Yeah.
One more, localization. Localization, yep. If you have translation,
Yeah, exactly, that as well. So Ali just said localization there, that happens as well. And then probably like one of the features that is hardly known, I'm just going to come to you in a second, is so you can also nest format strings. So this is a tiny bit ugly, but basically here you're starting a nested printing of the elements here. So you can define on the string level how you want to format nested structures. And here it's basically, we're starting a nesting here. We're going to use that format string to format these elements, and we can use all of them. And then, like after that, we have sort of the remainder, which is like in this case the comma. And here we're sort of saying, from here start the next element. So if any of you ever do code generation and want to sort of pretty print an array for some other language or whatever, this is the way to go. And combining this with map, so for instance, if we want to multiply those values by themselves, what is very nice if you take this array, you call map on them, and then multiply them, or do formatting on them if there's sort of special formats that have to be required there. And yeah, so there was a question over there.
Yeah, I didn't actually know about the comma in the numbers to make them formatted. And I also recently learned that in India, they do 3 numbers on the rightmost side, then they do pairs of 2 numbers at a time after that. Is that possible using this?
Yeah, so there are like std format is basically like a whole day of reading, like the documentation for it. And the really cool part is like all the formats trickle through write ln, so write fln, and 2 as well, and that is possible as well. So there's padding on the left as well as on the right. And then if that is not the case, you can always use functions in std string to really do what you need to. And it all composes nicely. So the last thing is, which I think is also undervalued, usually when you have a struct, normally what you would do, you have a toString. But because of introspection, you can just pass in the struct as a parameter to s, and it will just print the members recursively. Like, this is awesome for debugging. So if you ever see somebody doing a toString that basically just prints the values or the members of the struct, say, you don't have to do this, it's already there. So like the last things I didn't say that or sort of are needed, can find until and count until. So often you have to count, like to get an index inside of an array or random access range. And basically sort of a child of find is like there's count and until. And the other one that is interesting is can find. You think you can all, like writing find the range and then empty and then sort of negating that is the same as can find, but it's so much more readable to use just find. And prefix and postfix checking with start with and end with. And then we're pretty much there. So unfortunately, not everything is roses and rainbows. And so like if you brought tomatoes or everything else you can throw, please keep that in your bags for just now. This is sort of somewhat of a strong opinion, but I think it's right. So what, like Phobos, at least what I read on the internet and especially the forums, has a very bad rep. And yeah, I'm going to make new friends now very quickly. So common complaints is Phobos is using the garbage collection. And I would say as a humankind, as a race, we have not been, like, we're not smart enough to do memory by ourselves. Like we just shouldn't. It's just not worth it. Obviously, people say, but my case is special. No, it's not. Don't care. Just use the garbage collection and move on. Like if you want to fight me later, please. But I'm still not going to change my opinion. So exceptions are another complaint. People say, oh, but it's using exceptions. They are slow. Of course, exceptions are slower than the normal path, but it's in the name. Those are exceptional control flows. In the general case, you don't get them. And if you, for instance, think about this time from ISO string and parsing the time zone, this will go wrong. I guarantee you. At some point, this will go wrong. And what else are we going to do? Like return a nullable, but then we don't know what actually went wrong. Like if we return a result with this time and the error, you have to check that manually, and I know what the first complaint is going to be. This is so much manual checking, I don't want to do it. The other one, Erno, come on, it's like not the 1970s anymore. So exception it is. Everything else is as the emoji says. Like, I don't care what, it just is.
Cupcake icing?
Exactly, exactly. So another common complaint is there's too much coupling. And actually, when I sort of had an idea of what I wanted to talk about, I felt very smart while working out one day thinking, nobody has been so smart to, so when you have a sorted range, you can use binary search to see if there's an element in it. And I was like, nobody has modified find to actually do this. I'm going to like present a nice pull request and talk about that for 30 minutes or so. But actually, when looking into std algorithm search, there is already a special casing for when you pass in a random access, a sorted range. And it already does that. So you're basically getting a free win if you have a sorted range and pass that to find. Like suddenly you go from like a linear search, you go to log n because of coupling. And like another thing I think about coupling is people think of coupling in the sort of C-style way where there's sort of global data and functions modify that. But pretty much all the functions in Phobos are pure functions, even if they're not marked that way. And like, why would you re-implement find in 5 different modules? Use it, and then if somebody actually pass in a sorted range in a completely unrelated module, and you have to, in your algorithm in Phobos, search on that, you're going to get that free performance speed up for free. And I think that too much coupling is just sort of a red herring to say that, how to put this? Like people say if you use Phobos, your compilation gets slow. I think that is not a fault of Phobos. I think it's a fault of compiler. And if you want to fight me for that, please. But like, I think the opinion stands. And then auto-decoding, right? Like the thing we like to hate. Like coming from a country where not everything fits in ASCII, I think auto-decoding is the right choice. Like I think either you get like incorrectness by default. So if front would return just a character, not a dchar, some characters in German couldn't really work. And like that is just sort of a source of bugs that you don't want to get into. And then also, like most people don't even have parts of the Latin alphabet in the world. And I know sort of the D community mostly speaks English, but most people in the world don't. So I think auto-decoding, even though it might be slow, is the right choice. So things are missing. Obviously, I would like to have used an HTML parser, and we have none. And that needs to be in Phobos. There currently is no longer an XML library. We had that, but that was so atrocious we had to get rid of it, fair enough. But we don't have a replacement yet. And even though XML is really atrocious, like we have to parse it, and like we just can't. YAML also seems to be a thing, so we have to have a parser for that as well in Phobos. And here I would actually say to the people that sort of hate on std.json, so YAML and JSON at least fundamentally are supposed to have the same data structure. Why not like have two parsers that basically give you the same AST? Would be a nice project. So also typing, like if you do anything with like units like speed, temperature, and stuff like that, at some point you want to really strictly type your data and not just use double, because you don't know if it's in Kelvin or Fahrenheit or Celsius. And there are Phobos, there I would say D with all its meta-programming capabilities was really shine and sort of allowing you to do like computations on that data. Also, like the program I wrote is pretty much strictly sequential, even though like 99% of the time is just spent waiting. And having like something like event core from like the event system of Phobos of Vibe in Phobos would allow us to, or allow me in this case, to remove much of that waiting and start other processes. And then also, even though I couldn't find the example or I couldn't sort of make the PR to use the sorted range and find, I bet there are many other places where more coupling would even result in even better and even faster code. And then also, like, we can now with import C, and even before that, we were able to call C very simply. That was just not a problem anymore. And Python now has type annotations. And So why can't I call NumPy from Phobos? Like, why is that not a thing? Or why is the same not true for TypeScript or all the other scripting languages? Why can't I just use their standard library or their sort of associate libraries? Why isn't that a thing? And sort of the last thing, like the D frontend now is written in D. Like, why can't I use the D frontend at compile time to pass some decode and do some weird stuff? It really escapes me. All this needs to be in Phobos. And but back to the topic. Obviously, we need more people. And also, when we would have more people, I think there's a question at the back.
You're saying we need more people. Can you do the Steve Ballmer skit?
Come again?
Can you do the Steve Ballmer skit to get more people?
I don't know it, so I can't. Yeah. So even if we had more people, we still can't tell them to work on stuff, right? You can't just tell them, no, Ali, you do this now. Like, Ali would look at me, yeah, and would move on. But there's sort of one thing that brings me sort of back to my first DConf. I was very young and very green, and I was sitting somewhere where you guys are sitting. And Andrei Alexandrescu was on stage, and he was talking about purity. And then he complained that big int wasn't pure, and fundamentally it should be. I mean, it's basically just a big integer with unlimited digits. And I was like, I can write pure at those 2 function or 3 function calls. And that was my first pull request at DConf. And I think that is sort of the trick here. We can't tell, but we can ask nicely. And I'm not just saying we're going to put D out there and then people will write awesome libraries. Like, at that point in time, I was not able to write an awesome library. I was, again, pardon my French, a young idiot. Like, I had no idea. But I could write pure on a function. And that got me in here. And now I'm still here. So we can, I think what we should do is find small opportunities and present them in such a way that also very young people and sort of casual observers of D can contribute. And I bet they will stay because, as I said in the beginning, D is the best language and we have the best standard library. But the question, or the sort of the really coming back to the topic is, if we ask on issues.dlang.org, nobody will hear us. We have to ask where the people are, and they are at GitHub. So the too long didn't read, Phobos everywhere, and we have to move from Bugzilla to GitHub. And as I said in the beginning, if you brought tomatoes, stones, or whatever, now is the time. I think he was first.
Yeah. Have you talked with the LLVM leader for Bugzilla to GitHub integration?
I looked a bit into what they are doing, but I think their biggest problem is that they are also using from SVN to, so they basically have an SVN and Bugzilla, and they're moving like both things simultaneously to GitHub. Yeah. And I think like the moving from Subversion to Git is their bigger problem.
Yeah, I mean just the issues, because like one of the things that they did well was they put the GitHub accounts correctly when they merged the issues, and they also ported the closed issues.
Yeah, so like finding the right authors, that is trivial. Like that part was very easy. I mean, GitHub has a quite nice API, and because you're reading the issues in any way, finding the authors of them is somewhat easy. Like how to put this? Migrating the closed issues technically is also not that difficult. Like basically what you would do after you have created the new issues, you get a new ID, and you would run basically a find and replace on all the source code where issue IDs are labeled, and maybe have the old next to the new one or have the new next to the old one. That is not, like, how to put this? It's not a technical challenge. It's like, would we actually want to do that? And like, what part are we actually want to move? The technical part, like, you could write all that tomorrow.
Yeah, like I know that how they did that. They basically ported from Bugzilla to GitLab and then GitLab with GitHub Enterprise API because GitHub public API is not capable of doing most of the stuff. But yeah. I think it's a good thing to talk to him.
Fair enough. Yeah.
You mentioned that find knows that the range is sorted. So does the user have to pass in a flag, or how does find know that the range is sorted?
So there's a dedicated type, or the dedicated range type that is called sorted range. And yeah, and then you just do some bit of meta programming to figure that out.
Also mention assume sorted.
Yeah. Oh yeah, right. As Ali just said, there's also a function that is called assume sorted. Even like assume, basically as the name states, if you know that the thing is sorted, you can just call assume sorted without calling sort to sort the sorted thing again. And it just gets you like in a sorted range.
So just a minor comment about enforce. It's actually even more useful than you describe because it returns, it doesn't take a Boolean, it takes something that converts to a Boolean and then it returns it.
Yeah.
So if it's something that would return null, you have your check just in line.
Yeah, absolutely. Yeah, like all the code examples, all the implementations of map filter, enforce, zip, those are all like abbreviated versions to get the point across. Absolutely. Enforce is magic. Like if you want to have a good time, read the Phobos source code. Like you learn a lot. Cool. Everybody seems convinced. Not quite.
This idea of moving to the GitHub issues is very interesting, not just because of GitHub issues itself, but because there's a lot of other features that are side by side. Like one of the things that's very helpful is the GitHub wiki. So in principle, one thing that one could have is like a structured layout that kind of matches the internals of Phobos or the compiler. And it's in the source code itself, it has comments for people who are very proficient and know how everything works. But if there was like a parallel structure in the wiki that explained things for people who are just beginners or don't know or asking questions.
Yeah, some of that already exists, but I'm more of like the line thinking that like there's also the thing about the project management aspects of GitHub. There's actually sort of a project tab where you can sort of say these functions need, for instance, don't know, like no GC unit test if we actually want to go there, or like those assert messages need messages, not just assert false. And you can do that very fine-grainedly, and then you can basically have just a link on the sort of main readme.md saying, if you feel like contributing, have a look at all these projects, and they're sort of stuff for all levels of involvement that you want to take part of. And I guess sort of writing an error message or writing an assert message for one function there, that's not that difficult. But then also we could have a project of, hey, we are building out a new YAML parser that also is supposed to integrate into JSON. Like this is sort of the interface layout that we are thinking about. Come contribute.
Yeah. Earlier you had that slide with the long sequence of UFCS calls, and this is a bit nitpicking, but you kind of asked for it by saying that you didn't want to see certain things in code review, because that would not pass code review.
Why not?
By work, because you can improve that code massively by pulling the lambdas out into private lambdas at the bottom of the function, giving them nice descriptive names. Makes it a lot more readable.
Yes, but then also they're not in place, like you, right? There's always a judgment call there. And also, at some point it wouldn't fit on the slide, which is sort of a very easy way out for me to say right now. But often I find writing a small lambda in place and do a tiny bit of manipulation and call a Phobos function is most often the good thing or the right thing.
So there's definitely something that lives between a dip and a bug report. And that's kind of something that I know that some efforts have gone into project management in like the D Foundation has done some stuff. There was some Trello boards, and there's probably other stuff I'm not aware of, I haven't looked at. But that public-facing, integrated with everything else, hey, there's this thing we'd like to do. It's not huge, it's not a dip, nor is it just like, here's an example of a bug and a conversation over 3 years with some suggestions. It's like a clear project that someone can pick up. It is very valuable.
Like something you can sort of start on a train ride of 2 hours and be done by the time you get off the train, because like there's nothing you don't really want to do, like proper work, and just sort of play with the language and maybe get like integrated a tiny bit. Yeah, absolutely.
To prepare for the fight later, first shot. The problem with the auto decoding is not it's not that dchars are bad. It's that you've got something that's kind of a range. It's kind of a range of dchar. It's kind of an array of char. That's where all the nastiness is hidden.
Like what nastiness? Like what is actually bad about it?
Go read the code. It's horrible.
I have a nastiness example from 5 minutes ago. Just 5 minutes ago, I was toying with some code. No, not 5 minutes ago, an hour ago. And I was trying to do like a literal string, hello, dot retro, dot length. And that does not work. And you know why? Because of auto-decoding. So that it breaks in all sorts of unexpected ways.
Fair enough. Like at that point, I would say you're fixing that bug, but you're introducing another one.
So the thing you mentioned that are not in Phobos, they are there in the ecosystem and they are easily accessible. Event Core is a dub package. We have DML, which is a dub package. And I know what you're going to say. They're in dub. They're not as easily accessible as they would be in Phobos.
No.
So how do you reconcile that with Attila's goal to put Phobos on dub?
Well, as I'm the one on stage right now, Attila is wrong. Like, how do I put this? Yeah, I think it's just that. Like, I think it's...
Let's take this discussion outside after. Because I'm with Attila.
Yeah.
All right, we've got time for one last question.
Yeah, so just an anecdote about auto-decoding. So I think in Walter's talk, he explained how nice chain is. So he chained some strings and then iterated them by char. And I think what this will do is it will iterate the strings by dchar and then encode them back to char.
Yeah.
And yeah, I don't think that should happen.
Fair enough. I think you're wrong. No, like, how do I put this? Like, everybody here is an expert, pretty much, at DConf. But, like, how do I put this? Excel is the most widely used programming language by a huge margin, and they don't have those problems. And the next widely most used language is JavaScript. And, like, if we want those people here, and I think we want those people here, because they do awesome work and they do a lot of it, trying to explain to them all those problems is just, they're just going to turn around and go visit London. Like, they're not going to stay in this room here. And I think that is a mistake. And I think the performance problems and all the technicalities that we buy ourselves by having auto-decoding in there is worth the amount of people that we would keep. Like, obviously, I don't have hard data, but yeah.
So what you're saying is JavaScript is auto-decoding?
No, I'm saying that complicating those, like making string handling that much more complicated by not having it would just alienate those people. Like,
well, on that note, let's cut it off here. Thank you, Robert.
Thanks.